Okay, so those are the two wafers, and we also have a companion piece that we're going to use to measure thickness. So we are ready to pump down and deposit. It's not ultra high vacuum like in the PVD process, so this pump down is pretty fast. So I'm pumping down, and this shows all the status and temperatures and pressures. So right now my substrate temperature is 200 degrees Celsius. So normally 200 is too low to do CVD, but with plasma, the PE, plasma enhancement, allows us to do a CVD at this temperature. So right now it's pumping through this line here. That's the roughing line, and then it opens up the main throttle to pump through here. This is not a turbo pump. It's a blower style. It's called a roost blower pump. So it doesn't get down into microtorrs. It's millitorr range. Okay, now the main throttle is opening, and pressure, okay, there it is. It's coming down 150 millitorrs, 136, and it'll come down to a certain base pressure. So I'm going to go and edit the steps. I'll load what I have here for oxide. There's oxide. And this is developed over time. So initial step sets the starting point, 200 degrees on the substrate, 20 degrees on the walls. So that's 20 degrees is cooled by water. There's water lines running through the walls to keep it at lower temperatures so we don't get deposition on the sidewalls, because deposition on the sidewalls can flake and produce contamination inside. The base pressure we are aiming for is 25 millitorr. So that's a pretty high base pressure compared to PVD process. So that's all good. Next step is purge. We need to remove traces of oxygen. So that needs to be, that we're doing that by purging. So purging is nitrogen. Nitrogen is flowed for 2 minutes, and we bring the pressure back up to 500 millitorrs. From 25 millitorr, bring it up to 500 millitorr. Just hold it for 2 minutes. So we just kind of flush out oxygen that's in the chamber, because we're going to flow silane. Silane is very reactive, and it'll immediately produce silicon dioxide in the gas phase, which is not what we want. Next one is pump down to 25 millitorrs again. Hold it for 10 seconds. This is the process step. Number 4 is the process step. We're going to run it, okay, it's 10 minutes. 10 minutes is how long we're going to run it. And the deposition rate that we measured previously was 2.1 or 2.2 angstroms per second. Pressure is 1500 millitorrs. That's 1.5 torrs. We are flowing silane, flowing nitrous oxide. These are the two gases that combine to produce SiO2. The byproducts are nitrogen and helium, because inside the silane, this is not 100% silane. It's actually, I think it's 2% or 2.5, or yeah, something like that. It's a couple of percent. The rest is helium. So there will be helium as well. And the power we're going to use is just 10 watts. That's all you need to dissociate the silane and the nitrous oxide to reduce the activation energy, so it'll react at 200 Celsius. So that's what's happening there. After the deposition, we're going to evacuate, remove all traces of silane, because we don't want it to react with air. And then we purge again for 2 minutes, just like the initial purge, and then we end. So let's go do that. So I don't need to save it because I didn't change anything. Load, it's loaded. Okay, ready. Waiting for ready temperature. Why is it ready? The temperature is already good. Okay, compliance is achieved, and I just run it. That's it. So this is step 1, is waiting for the initial condition. Base pressure of 25 millitorr. It's at 26, so it wants a little bit more time. Yeah, that purple glow is the Yeah. And then the wafers are in there. You can barely see them. It's an atmosphere, so we're going to open it up. And there are the wafers. So I'll take the companion piece out first. So there's the companion. You can see it is blue, like the royal blue. So I'd say it's a pretty close, between 1,000 and 1,200 angstroms in that neighborhood.